breaking vectors into components by hand. Breaking vectors into components is essentially the reverse of adding vector components to find a resultant. As with adding components, there are two methods, by hand and using trig. This video goes over drawing the vectors by hand. If you want to use the trig method, watch the video Breaking Vectors into Components with Trig. Find the horizontal and vertical components of the vector below. To find these components, we need to set a scale just like we did for adding vectors. Then we'll draw the given vector, measure the components, and use the scale to convert back to newtons, or whatever the original units were. To set the scale, we need to accommodate a 20 Newton force. Let's try a scale of 1 centimeter equals 4 newtons. Using our unit conversion method, that means the vector will be 5 centimeters long. Ideally, you'll want your vector to be somewhere around 5 to 8 centimeters long, so it's big enough that it's easy to measure and small enough that it fits on the grid. To draw the vector, I'll start in the lower left, since I know this vector goes up and to the right. I'll draw a dot as my starting point. Before continuing, we'll need to determine the direction of the vector. If you have a protractor available, it might help to use it to follow along. We'll place the center at the dot that we just drew and align the 0 to be in the direction the angle is measured from, in this case, the positive x-axis. It's 30 degrees, so I'll draw a dot at 30. That's the direction of the vector. We already found the vector needs to be 5 centimeters long, so we'll line up the two dots and measure 5 centimeters in that direction. That gives us our scaled vector, which is the resultant of some two components. Next, we'll go ahead and draw each component to make it easier to measure. Keeping in mind the two components add to get the resultant in tip-to-tail fashion, we should have a vector to the right and up. Make sure to use the grid to keep the components as close to horizontal and vertical as possible. Now we can measure them. The horizontal one looks to be about 4.3 centimeters. And the vertical one looks to be about 2.5. Lastly, we can use our unit conversions to convert these back to forces. 4 times 4.3 is 17.2. That's in the positive direction, so the horizontal component is 17.2 newtons. .5 centimeters times 4 is 10 newtons. Again, in the positive direction. So my vertical component is 10 newtons. Let's repeat the process to find the components of the next vector. So let's try the scale again of 1 centimeter equals 2 newtons. This 12 Newton vector will be drawn 6 centimeters long. It goes up and to the left, so I'll start at the bottom right with a dot. Notice how this force is measured from the negative x direction. That's fine, we'll just need to make sure we use angles as measured up from the left or from the negative x direction as shown in the picture. So I need to measure up from the left. I'll make my second dot at 65 degrees. It's way off the grid, but that doesn't matter, because I'll only be going 6 centimeters in that direction. There's my scaled vector. Next, we'll sketch the two components. And measure them. The horizontal one looks to be 2.5 centimeters, and it's to the left, so it's negative. The vertical component looks to be 5.4. And it's up, so that's positive. Lastly, my unit conversions. Gives me a horizontal component of -5 newtons and a vertical component of 10.8 newtons. Okay, one more. This one has a force of 15 newtons. So let's try a scale of 1 centimeter equals 3 newtons. This means the 15 newton force will be 5 centimeters long. This one goes up and to the right, so I'll start at the bottom left. This one's tricky because this angle is actually measured from the vertical axis. All that means is when I line up the center, now I'm measuring with 0 directly up. It's 75 degrees, so I'll need to count up from there. 75 degrees looks like it's about over here. I can measure 5 centimeters in that direction. And there's the scaled vector. Sketching the two components. I have one going to the right and one going up. Measuring each, this looks to be about 4.8 centimeters in the horizontal direction. And maybe 1.3 in the vertical direction. Lastly, I'll use unit conversions. .8 times 3 is 14.4 newtons. That's in the positive direction. And 1.3 centimeters times 3 is 3.9 newtons, also in the positive direction.